Welcome to The Explainer. Today, we're diving into a really critical moment, that split second when a human pilot has to wrestle control back from a highly automated drone that's gone off script.
So just imagine for a second, you are flying a multi-million-dollar aircraft, but you're nowhere near the cockpit. Your co-pilot? It's an algorithm, and in the blink of an eye, it does something that makes absolutely no sense. This isn't some sci-fi movie plot. It's a very real-world scenario for the pilots of uncrewed aerial vehicles, or UAVs.
So let's explore this high-stakes world, where that crucial teamwork between a human and machine can just completely break down in an instant. I want you to really put yourself in the pilot's seat. You've got none of those physical cues a traditional pilot just takes for granted. There's no engine roar, no feeling of G-forces, none of that gut feel for how the aircraft is responding. Your entire world, your entire reality, is what you see on a screen. And yet, you are legally on the hook for every single thing that aircraft does. And this situation leads to a phenomenon researchers call automation surprise. It's that jarring, gut punch moment of confusion when the machine's actions just don't line up with what the pilot expects. The pilot is left totally scrambling, asking, what is it doing? Why is it doing that? And what on earth is it going to do next? So, to prevent these kinds of dangerous surprises, researchers first had to figure out what's going on inside the pilot's head during these critical moments. How do they actually make sense of the chaos? To get at this, researchers used a method called T-swarm, and what they found was pretty fascinating. They discovered that over half of a pilot's crucial information comes from the world, which, for a UAV pilot, means pretty much everything that's being displayed on their control station screens. Okay. So this T-swarm model, it's basically a constant high-speed loop. It all starts with schema. That's everything inside the pilot's head. Their training, their experience, their gut feeling. Then comes the world, all that data flooding in from the displays. And finally, action, the actual decision the pilot makes. It's this non-stop cycle of seeing, thinking, and doing. So, with this framework in hand, the researchers analyzed interviews with real, experienced UAV pilots talking about actual incidents. They wanted to pinpoint the things that matter the most when things start to go sideways. And wow, this chart, it really gets to the heart of the problem. Just look at the top factors pilots brought up over and over again. They're all about the interface. Display indications is number one by a country mile, followed right behind by simply understanding the UAV status. It all comes back to the information on that screen. So what does this mean? It means the single most important tool a UAV pilot has is also one of the most common points of failure. When those displays are confusing or cluttered, or they just hide the key information, that pilot is basically flying blind. And this is why human-centered design is so incredibly crucial. For example, pilots said that looking at a static number on a screen makes it nearly impossible to spot a dangerous trend. So, what's the solution? Well, design displays that actually show you trends and projections over time. They also miss those physical cues, like the sound of an engine. So why not add synthesized audio cues to give them that missing layer of information? And all of this, it all boils down to the most important and honestly the most fragile element in any human-machine relationship: trust. You can't just tell a pilot, hey, trust the system. It doesn't work that way. Trust is earned. It's built through hands-on experience, through clear, unambiguous information, and through a deep understanding of how the system thinks. And it can be broken in an instant by confusion and a lack of transparency. The second a pilot doesn't know what the system is doing, trust just evaporates. And you don't have to take my word for it. This quote from one of the pilots in the study, it just says it all. The link between understanding and trust is absolute. If you don't know what it's doing, you simply can't trust it. It's really that simple. At the end of the day, any automation that feels like a mysterious black box will never ever be a true partner. Predictability and transparency, those are the real foundations of a successful team. So the big question is, what do we do about all this? How can these insights actually help us build better, smarter systems? Well, fortunately, the research gives us a pretty clear roadmap. And the recommendations are really direct and practical. First, design displays that show you the trends, not just a snapshot of right now. Second, add more sensory info, like sound, to replace what's lost by being so far away.
Third, train pilots not just on the what, but on the why behind the automation's logic. And above all else, follow human-centered design principles from the very beginning.
Really, the ultimate goal here is a huge shift in thinking. We need to stop designing automation as just a complex tool that we operate and start designing it as a transparent, predictable teammate that clearly communicates what it's doing and what it's about to do. And that brings us to the final crucial question, because let's be honest, this isn't just about drones anymore. Automation is becoming a co-pilot in our cars, a manager in our workplaces, an assistant in our homes. The lessons we're learning here are universal. So how do we make sure we design these systems not as frustrating black boxes we have to fight with, but as true partners we can actually understand and ultimately trust?